Hello friends, this lesson is all about questions on first law of thermodynamics. I have cleared all your theoretical concepts on first law of thermodynamics, results of first law of thermodynamics, different equations of first law of thermodynamics, steady flow energy equation, closed system analysis, open system analysis. You can go through these previous lessons and revise those concepts with the help of these problems. This is a kind of mock test for all of you. First of all, try to solve these questions on your own, then you can see the answer key which is at the last slide. But before proceeding further, I would like to introduce myself. My name is Harshit Agarwal. This is all about me. You can always rate, review, recommend and share this lesson. You can also follow me on the specified link. So to start with, first of all, try to solve these problems on your own. To start with the very first question. The question says, the enthalpy drop for flow through a convergent horizontal nozzle is 100 kilojoule per kg. Enthalpy drop is 100 kilojoule per kg. If the velocity of approach at inlet to the nozzle is negligible, if the velocity of approach C1 is equal to 0, the exit velocity of the fluid is. See, this question is related to steady flow energy equation, and if you remember in the applications of steady flow energy equation for nozzle, we have derived one equation h1 plus c1 square by 2 is equal to h2 plus c2 square by 2. The enthalpy drop, that is h2 minus h1, is given as 100 kilojoule per kg, right? And inlet velocity is 0. So the equation comes out to be h1 is equal to h2 plus c2 square by 2, right? This is the equation. V1, C1 or V1, velocity V1 is 0, so V2 is equal to under root 2 times H2 minus H1. It is in kilojoule, 100 kilojoules. That's why it is given as 100 kilojoule. That's why I have taken as 100 into 1000. Always keep your numericals in SI unit, joule form. Then only you will be getting the right answer. Don't forget to convert kilojoule into joule. So velocity, exit velocity is equal to under root 2 into 100 into 1000. So exit velocity is equal to 447.2 meter per second. As you can see, answer is C. For this particular question, the answer is C, 447.2 meter per second. Here comes the second question. In a cyclic process, first law of thermodynamics, if you will remember, net heat transfer is equal to net work transferred. Sigma Q is equal to sigma W. Heat transfers are plus 30 kilojoule, minus plus 30 joule, minus 50 joule, minus 10 joule and 60 joule. We have to find the net work transfer for the cycle. Net heat transfer is equal to net work transfer. If you will calculate the net heat transfer, automatically you will be getting the net work transfer. So for net heat transfer, sigma Q is equal to sigma W. It is given as plus 30, minus 50, minus 10, plus 60. Plus 30, minus 50, minus 10, plus 60. The net comes out to be 30 kilojoule. So the net heat transfer is equal to 30 joule, which is answer A. Newton meter is 30 joule. These two questions are pretty much easy. Next comes the third question. It says, first of all, try to do this on your own by integrating Euler equation between sections 1 and 2. I have explained you this particular thing in steady flow energy equation. You can go through the open flow system. By integrating Euler equation between two sections 1 and 2, for flow of an incompressible means density is equal to constant, incompressible inviscid fluid through a pipe, we get what? Steady flow energy equation, Bernoulli's equation, continuity equation on variable flow equation. Inviscid, incompressible, that is no viscosity, density constant through a pipe, we will be getting what? Bernoulli's equation. The answer to that third question is Bernoulli's equation. Fourth question. Mass flow rate is given as 0.70 kg per second. 0.70 kg per second of air enters with a specific enthalpy of 290 kilojoule. Mass flow rate is 0.70. H1 is equal to 290 kilojoule and leaves it with 450 kilojoule. H1 is equal to 290, H2 is equal to 450. Velocities at inlet and exit. Velocity at inlet is 6 meter per second and exit it is 2 meter per second. Assuming adiabatic process, that is Q is equal to 0, what is the power input to the compressor? Mass flow rate is given as 0.70, H1 is 290, H2 is 450, C1 is 60, C2 is 2. Assuming adiabatic Q is equal to 0, what is the power input? We have to calculate the power input to the compressor. So we will first of all use the obviously the steady flow energy equation. Mass flow is given as 0.7, H1 290, H2 450, V1 velocity V1 6 and V2 2 meter. See here V1 and V2 are the velocities. So power input is equal to mass flow rate into H2 plus V2 square by 2g minus H1 plus V1 square by 2g. It is power input to the compressor. And while calculating this, while deriving the steady flow energy equation, we have taken work done as work done by the system. So if it would be a टर्बाइन, अगर यहाँ पे टर्बाइन होता तो हम लिखते H1 plus V1 square by 2g minus H2 plus V2 square by 2g. लेकिन यहाँ पे क्या है, यहाँ पे जो है कंप्रेसर है, इसलिए हम लोगों ने that's why we have taken H2 plus V2 square by 2g minus H1 plus V2 square by 2g. If you will put these values in this mass flow rate, enthalpy, velocity, keep in mind it is 450 kilojoule, that's why it is 2 square by 2 into 1000. It is V1 square 6 square, that is why 2g 2 into 1000. So the power is equal to 112 kilowatt. I think this is pretty much clear to you all. Next question. In a throttling process, which one of the following parameters remains constant? As I have already told you characteristics of throttling, the first important characteristic was there is no heat transfer, right? There is no work transfer. It is an irreversible process. Constant enthalpy, isenthalpic process. These are the important characteristics of throttling process, which I have discussed with you in the applications of first law of thermodynamics. So just go through this. The answer for this is C, enthalpy. Question 6. Gas contained in a closed system consists of piston cylinder arrangement is expanded. Work done by the gas during expansion is 50 kilojoule. Decrease in internal energy of the gas during expansion is 30 kilojoule. Heat transfer during the process. If you will use the equation for the first law of thermodynamics, dq is equal to du plus dw. Work done by the gas is taken as positive and work done on the gas is taken as negative. So this is plus 50 kilojoule. Decrease in internal energy during expansion is 30, it is minus 30. So if you will use this equation, dq is equal to du plus dw. dw is equal to 50 kilojoule, du is equal to minus 30 kilojoule. So dq is equal to du plus dw. du is equal to minus 30, dw is equal to 50. So dq is equal to 20. So answer for this is 20 kilojoule, that is B. The answer for question number 6 is B. Seventh question. In a steady flow adiabatic turbine, the steady flow, that means you have to apply the steady flow energy equation. The changes in the internal energy. See, in steady flow there is no concept of internal energy as such if enthalpy is given. See, changes in the internal energy and enthalpy both is given. And enthalpy is what? U plus PV. So you can remove this concept in this particular problem because change in enthalpy is given, which is minus 40 kilojoule per kg. Changes in kinetic energy is given minus 10 kilojoule per kg. Changes in potential energy is 0. Which of the following gives the amount of work developed by the turbine? Changing in internal energy don't take into account. Changing in enthalpy is what? Minus 140 kilojoule. Change in kinetic is equal to minus 10. Potential energy is 0. So you have to just keep in mind change in the enthalpy and change in the kinetic energy, and you have to calculate this particular problem. So we are going to use the steady flow energy equation. Mass flow rate into enthalpy plus kinetic energy plus potential energy plus Q. Mass flow rate into enthalpy, kinetic energy, potential energy plus W. Neglect heat. Steady flow adiabatic is given, neglect Q. Neglect potential energy. So potential energy 0, neglecting heat. So it is mass flow rate into H1 minus H2 plus V1 square by 2 minus V2 square by 2 is equal to W. We have to find the W, which is difference in enthalpy, H1 minus H2 plus V1 square by 2 minus V2 square by 2. H1 minus H2 is minus 140. So you will write minus 140 and changes in kinetic energy is minus 10. So W is equal to 150 kilojoule per kg. You have to keep this in your mind. This is the answer D, 150 kilojoule per kg. Keep these results in your mind. Keep these numerical problems. Try to solve them at least twice or thrice. If you want more problems to be solved, if you want more objective question, just let me know. I'll be giving you that. If you have any doubt, just ask in the comment section. Do not forget to rate, review, recommend, and share this particular lesson. At least share all the lessons, recommend and give rating for all the lessons, so that it would be helpful for me to give you more better courses. Right, this is the answer key for all the questions. If just go through them. Thanks a lot from my side. This is Harshit Agarwal. Thank you all.